In this video, we're going to talk about guitar pickups. This video was made by my partner Adam Novak and myself, Oscar Mazones. Before we explain how a guitar pickup works, we need to understand first the basic principles behind it. The main principle that is behind it is going to be Faraday's law. Faraday's law establishes that a changing rate of flux in a closed loop induces a voltage in its terminals. As it can be seen here in the in this slide, this formula establishes that the number of coils times their changing rate of flux is going to give us a voltage established in the terminals as seen right here. There's two ways to accomplish this voltage or this changing rate of flux. There's two ways. The first one is going to be by varying the B field that is going to go through, or the amount of lines that are going to go through the area, the surface, or the area enclosed, or you can change the area, the amount of area by just moving the loop around, but with the same B field going through it. This is important because magnetic pickups or guitar pickups, what they use is this principle right here. They use Faraday's law, but by changing the B field. Magnetic pickups or guitar pickups are comprised by three elements usually. It is going to be the metallic base, the encrusted magnets, and the coil wire. As seen in these pictures, the metallic base is going to be actually these two black parts that are right here. These two. These are going to be the magnets that are encrusted, and we're also going to have the coil of wire that is going to be right here. So basically a magnetic pickup is equivalent of saying a guitar pickup. The magnetic pickups are going to produce a magnetic field around this coil and around the whole figure that is going to be picking up, as its name says, any disturbance on this magnetic field that is produced by it. So if we put anything, another magnet right here, or we put another magnet here, that are going to create a variation, and we start moving those magnets in and out, we're going to create a varying magnetic field that is going to induce a voltage in both of these terminals of the coil. This is what a magnetic pickup is actually doing, is measuring its own field and picking any disturbance of the magnetic field in here. So if we put anything with a magnetic field that interferes with this one, we're going to see a voltage right here. And depending on how that magnet or material or another field is interfering with it, is going to be the shape of the voltage that we're going to see whenever we're reading this coils. Now, for how it actually works for a guitar pickup. This pickup is a little bit different because it actually uses a bar magnet, but it's the same principle. What we need is going to be these strings right here they have to be ferromagnetic. Why? Because once they're ferromagnetic, they're going to be able to be magnetized by this field, and then when they are moving, because they are magnetized, they are producing an electromagnetic field, and they move, we're going to see, or actually the pickup is going to pick up a voltage because there is a changing magnetic field due to the movement of the strings. To see it better, we're gonna draw here a bar magnet, which is going to have a north and a south, and we're going to see the field lines produce from it, and they're going to go in this direction. Now, this magnet is always magnetizing the string that is going to be on top. Now, this string, as seen here, when it moves, and because it's magnetized, it's going to produce a very magnetic field in here, in this area right here, because this string, actually, if we do a dipole of this field, it's going to have the same direction of the top, and it's going to interfere with this magnetic field with their own lines, right? So if we see it here, we're going to have a different or a very magnetic field, because when this goes up or down, the amount of lines that are going to pass by this area where the coil is at is going to induce a signal or a voltage. It's also important to know that these coils or these pickups doesn't necessarily need a bar magnet. Why? If the strings are already magnetized by some other magnet or by some other coil or something that is in the guitar, we don't actually need to have a magnet. Why? Because the coil is going to feel a varying magnetic field that is going to come from the vibrating itself. It's not going to be the interaction of the bar magnet with the string, of the field, I'm sorry, of the magnet with the string, and it's going to be actually the vibrating string that is going to create a varying magnetic field.
I'm going to be doing a live demonstration of the guitar pickup. To begin, all I'm going to be doing is explaining the functionality of the guitar and how it works, and also open it up so you can see the components on the inside, and I'll explain the functionality of each component. Then after that, I plan on tapping into one of the guitar pickups and measure the voltage induced by strumming the guitar, and also going to change the tension of the strings so that you can see how it impacts the frequency. We'll measure that on the oscilloscope of the DAD board, and I also will play some tunes through the amplifier so you can hear the difference in the frequency. And then after that, I have created a small mini version of a guitar pickup, just like a very easy replica, and then also demonstrate how the electromagnetic induction works on that, and it also to produce a small voltage compared to these pickups. So we'll go ahead and start, and go ahead and open up the guitar and get explaining that for you. All right, so gonna start with an overview of how the guitar works. Essentially, there are the three pickups. You have the neck, mid, and bridge pickup, and those are obviously what produce the voltage once the guitar string is strummed. And then there's a switch here that determines which signal from the pickups is going to be used. So if you have it in the switch in that position, only signal from this pickup gets sent out to the amplifier. And then this position, it's these two pickups. This position is solely the mid pickup. This position, mid pickup and bridge pickup, and then the last position there is just the bridge pickup. And then you have, this is a volume control, simply as a potentiometer. So if you have it so that the volume is 0, it's the potentiometer has the highest resistance possible. And in that case, the signal just gets sent to ground and there's no actually signal output to the amplifier, versus when you have a 10, it's most likely that the potentiometer is set to have a very low resistance, and that way the signal can actually get output to the amplifier. And these are the tone dials, which are a combination of potentiometer and also capacitor. They are an RC circuit that basically filters out the frequency so you can change the tone. And this tone is solely for the neck and the mid pickup, whereas this tone is for the mid and the bridge pickup. So you can alter the tone for the music played. So now I'm gonna go inside and explain what's happening on the other side of this. All right, so on the other side here, we have the three pickups, neck, mid, and bridge, and each of them have their positive and negative signal coming out of them, which is fed to the switch there, which determines which signal is going to be sent to the potentiometers, which then determine the volume, the tone, the frequency of it all, and then that is then sent out to the amplifier to produce the tone that you hear. So now what I'm going to do is tap into the wires here just for the neck pickup and strum the strings and see what type of voltage output we get, what type of frequency we get, see what's actually happening there. All right, so I've gotten everything back together now, the strings back on, and got the neck pickup. I tapped into that, soldered some wires to it, and it goes to the oscilloscope of my DAD board, and I'm going to be displaying the voltages there. So what I just want to first demonstrate is that by simply strumming the guitar, it does in fact disrupt the magnetic field of the pickup, which does then induce the voltage in the coils, which we can then pick up on the oscilloscope. So we have a flat line there, diddly, I'm going to strum it, and you get voltage. It's not a huge order of voltage, however, if you do see that, it is up to 100 millivolts. So the strumming of the guitar there does produce about 100 millivolts from the pickup, but that does show that the disruption of the magnetic field by the guitar string does in fact produce a voltage. All right, and now I want to demo how changing the tension of a string can affect the frequency of the outputted waveform. So these knobs over here allow the player to adjust the tension of the string. By making it tighter, it would imply that it would be a higher frequency versus if the tension was less, it would be a lower frequency. So I'm going to tighten it up and strum it and just run a few singles here. See around 170-ish, 180 volts. Now I'm gonna let the slack off a little bit. Let me make sure. And now back here, 89, 89, 89, 89, 89, 90. So you see that the more tense it is, we can read that the different frequency produced. All right, so now I just want to put the frequency example that I just showed you on the waveforms there into example with actual live music from the guitar amplifier. So I'm going to strum it. You hear a relatively deep, kind of low frequency noise. So now I'm going to strum it and then tighten the string really quickly, and you'll hear the frequency increase. So just another supporting factor there, that tightening the string increases the overall frequency that the string vibrates at, and thus the frequency of the voltage induced in the coil too also increases. So that way when you strum all the strings together, you get all that, it's just all the different frequencies. And also to demonstrate, I created a replica guitar pickup. Essentially all it is a permanent magnet wrapped in copper coil. I use 42 gauge coil because that's what they use from the manufacturer for these guitar pickups. And although guitar pickups are actually wrapped with around like 8,000 coils, I stopped around 500 because that's all I could handle. So I'm just going to demonstrate that even something with just like 500 coils wrapped around a permanent magnet can create a voltage, have a voltage induced due to electromagnetic induction with just 500 turns. So although I probably won't get anywhere near 100 millivolts as the guitar pickups produce, I should get something. So I'm going to strum the string and see what we can get on the oscilloscope. So there's that.